Chapter 4, Section 2, Logarithmic Functions. So you should have read through this section. And it talked about logarithms. Now, logarithm is just an exponent. It's the inverse of the exponential function. So we say no horizontal line can be drawn that intersects the graph of an exponential function at more than one point. This means that the exponential function is one-to-one, and it also has an inverse that is a function because it passes the horizontal line test. The inverse function of the exponential function with base b is called the logarithmic function with base b. So these two equations, y equals log base b of x, and b raised to the power of y equals x, are different ways of expressing the same thing. So I always tell students to memorize the phrase log is exponent. Because later when we solve logarithmic equations, we're going to want to convert the log equation into an exponential equation. So if I read this backwards, this says log is exponent. So we take the base, this right here, because this is read as y equals log base b of x. So if log is exponent, let me say b, the base, raised to the power of y equals x. And that's what this says right here. B raised to the power of y equals x. So it'd be easy to convert it if you know log is exponent. This first equation is in logarithmic form, and the second one is in exponential form. Notice that our logarithm, y, is an exponent. Okay, right here. You should learn the location of the base and the exponent in each form. Okay, your book then talked about, which one's the base, which one's the exponent. So we're going to change from log form to exponential form. Sometimes it says 3 equals log base 7 of x, or over here in part C, this is log base 4 of 26 equals y. But you do the same thing. It almost makes like this spiral thing where like base 4 to the power of y equals 26. Okay? Base 4 to the power of y equals 26. Base b to the power of 2 equals 25. Base 7 to the power of 3 equals x. Okay, and that allows us to solve these mini equations if we're able to convert them. But remember, log is exponent. All right, change from exponential to log form. Well, here I'm seeing that 2 is the base. All right, so if log is exponent, this is going to convert into log base 2 of x equals 5. So we have still this like spiral thing going on. Okay, log base 2 of x equals 5. Log base b of 27 equals 3. Okay, you can kind of see that spiral thing going on. Log base e of 33 equals y. Okay? So if you have questions or you're having difficulty converting from exponential to logarithmic or logarithmic to exponential, just let me know so I can help you. Evaluating logarithms. Now this chart should have been filled in. Hopefully you did fill that in. If not, then put a little bit more writing in your notes. Evaluate. Some of these can be evaluated into a single value, like an integer. Okay, and those that you can evaluate, you must evaluate. It's kind of like if you're working with radicals and you end up with the square root of 144. You wouldn't leave it like that because it can be evaluated. So can these. Okay, so my question then is, it kind of looks like this, even though we don't write it like that. So we're like 10 to what power equals 100? Okay, and that's what I have written right here. Log base 10 of 100. 10 to what power gives 100? right? This would be like 10 to the x equals 100. All right, well, log base 10 of 100 is 2. Why? Because 10 raised to the power of 2 is 100. Same thing with this one, log base 3 of 3. 3 to what power gives 3? Well, 3 to the first. So log base 3 of 3 is equal to 1. This one, a little bit tricky, but still not terrible. So we're like 36 to what power equals 6? Well, we know the square root of 36 is 6. And the square root, when we convert it from radical form to rational exponent form, it's 1/2, right? The square root of 36 equals 6. So 36 to the power 1/2 equals 6. Okay, and so we see this x then equals 1/2. All right, so if you have questions, let me know so I can help you. All right, basic log properties. Because logarithms are exponents, they have properties that can be verified using properties of exponents. Log base b of b is 1. Why? Because 1 is the exponent to which b must be raised to obtain b, right? This is b to the first equals b, which it does. b to the first is b. This one here, log base b, and this applies to any base, okay? Log base b of 1 equals 0. Why? Because b to the 0 power equals 1. Remember, any base, as long as it's not 0 raised to the 0 power, equals 1. All right. Now, you're going to see these like as such, log base 9 of 9. It doesn't matter what the base is, as long as these two match, this is always going to equal 1. 9 to the power 1 is 9. 15 to the power 1 would be 15. So if you have log base 9 of 9, that's always going to equal 1. Log base 15 of 15 is going to equal 1, and so on. Log with any base raised to what power is going to give me a 1? And it's going to be the 0 power. Okay, so these you should automatically replace and substitute. You know, so later on you're going to see when we solve equations, you might end up with something like this. This would need to be replaced with a 1 because this can be evaluated and simplified. All right, this part here, not really difficult, if you will. This is just illustrating. The inverse of the exponential function is the logarithmic function. Thus, if f of x equals b to the x, then f inverse of x equals log base b of x. We saw in chapter 2 how inverse functions undo one another. So if we find f of f inverse of x, that would equal x, and f inverse of f of x also would equal x. So I just did a little recollection here. If we recall, f of x is 4x minus 7, and the inverse, when we went through that process of replacing the f of x with y, switching the x and the y, and solving it, we would end up with this function right here. And if we found f of f inverse, that equaled x, and f inverse of f, that also equaled x. So that verified that those two functions were inverses of one another. Inverse properties of logarithms. Remember, again, the base has to be bigger than 0. It's got to be a positive number. And it also cannot equal 1 because it's not exponential then. All right, so here's my basic function. F of x equals b raised to the x power, and my inverse function, log base b of x. Log base b of b to the x equals x. The logarithm with base b of b raised to a power equals that power. Folks, this is f inverse of f of x, right? Because f inverse is our log base b of x. Here, b, the base, raised to the log with the same base, b of x, that also equals x. Okay, this one here is f of f inverse. So b raised to the logarithm with base b of a number equals that number. Okay, so as long as these bases are the same, it's always going to equal the exponent. Again here, this base raised to the log of the same base, is always going to equal that value right there. So if I look at these two examples where I have to evaluate, notice log base 7 of base 7 raised to the power of 8. As long as these bases are the same, it equals the exponent. Okay, so that's why this problem equals 8. Now here I have base 3 raised to the log base 3. Bases are the same again. It's going to equal this value right here, 17. So those are things that need to be learned. And when you look at it, you should be immediately able to evaluate that. If you have questions, please let me know. And that looks like it's it here with up to example 5. The next section, you're going to be graphing logarithmic functions. So make sure you're using graphing paper. And I'm going to give you a hint for those graphs. Okay, you're going to be graphing logarithmic functions. And remember, log is exponent. And also remember that the logarithmic function is the inverse of the exponential function. Excuse me. So for these graphs, if you instead choose the y's to get the x's, it's going to work. Or if you are asked to graph y equals log base 2 of x, okay? Convert this to exponential form. Okay, so b to the power y equals x. B to the power y equals x. What I'm trying to say here is get the table for the exponential function and switch it, right? So we are used to choosing the x values. Okay, but for the logarithmic functions, choose the y's because those are the exponents and it's going to be, right? Log is exponent. So choose the y's instead to get the x's. Okay, say to yourself, 2 to the power negative 3 is 1/8. All right, so work it backwards. That's my advice for those right here. And then 2 to the power negative 2 equals what? 2 to the negative 2 equals 1/4. Right, that's 1/2 squared. And you can get the table a whole lot better for these graphs. Remember, I know some of you are using the graphing calculator, but it's going to give you decimals. If it even gives you values, you have to like change something in the calculator in the window so that you're able to see these decimals. I'm not really interested in decimals. So just think of it this way. Since we know the log function is the inverse of the exponential, when you're making your table, choose the y values, right? Because remember, in the inverse tables, the x's and the y's switch places. Okay, that's all I got for today. If you have any questions, please let me know. Have a great day.